I think
I've clicked it,
it's
Charles.
showing as recording. So maybe, has somebody done that for me?
Yep, I've done that.
It is recording, yeah.
Thanks, Kylynn. So I'm going to share my screen now. I've opened, I hope, in something that is familiar to you, which is the International Snomed CT browser. And I just wanted to very briefly show you a couple of things just to navigate. So one of the things we're going to look at this morning is chronic lung disease. And you'll see that I put in 4 characters here, COPD, and it finds me a number of terms which where COPD or chronic obstructive pulmonary disease is listed. I can bring that over, and the things I wanted to just show you here is that there, not only do I see the parents of the term, so chronic obstructive lung disease is a child of chronic lung disease or bronchiolar disease. It has those relationships. Its clinical course is chronic. Its finding site is bronchiole structure. It has an associated morphology, so you can actually sort of imagine your lung here. So your tubes are where COPD happens, and one of the reasons it happens is that your tubes get narrow, so you get short of breath because you can't get the air in. And there is a function here where if I knew the grammar of expression constraint language, I would be able to write an expression. I can also begin to do that by grabbing a term and putting it into the expression constraint query language window. But I would need to know the grammatical structures to do that. So rather than do that here, I'm going to now just flick over to the ECL builder, and maybe I'll just start from scratch here. So I can, if I just scoot down here, or let's create a new query. So if I go to the sort of right to the beginning, Snomed has 600,000 concepts, and I want to try and find a group, a cohort within that. So I might say, well, I'm interested in the disease of chronic obstructive airways disease. So let's define a disease. And there we are. So here is the top end of the category disease. And let's just shrink that. And I want to find a particular one. So I'm going to put in some relationship constraints. So I'm going to find at least one of the self and descendants of a disease that has a finding site, which is lung. So I'm going to put in finding site. And there it is. It's equal to, and I need obviously to find something that has a relationship to finding site. So let's try lung. And I've got lung structure. I don't want to put lungi in. That's a kind of cloth. I don't want lung status. I don't want a vanishing lung. I want the structure of the lung. So I add that in. And already, I've created a bit of ECL that's now written out here. And I'm going to further define it by adding a further constraint. And so I find one and the descendants or self of a disease that has a clinical course equal to chronic. And if things were working well, which they aren't right now, and I can't quite work out why, I would find a set of terms that match that expression constraint query.
Charles,
Can you?
The disease just needs to be descendants or self.
Oh yeah, okay. So all I'm finding is the top code, and I think I could do with spelling that clinical course correctly. So there we go. And so I've just corrected some spelling. It is very important to always look for the descendants of a concept as well as itself. Otherwise, you get only one thing returned or nothing returned. And you'll see that here I have a set of concepts related to chronic lung disease. Now, one of the things I'm going to do just for this demo is to copy this bit of ECL. So I press the copy button, return to the browser. I'm going to rub that out, and I'm going to put that expression in and execute it. And you'll see, and I hope you're not surprised by this, but it's sort of reassuring, isn't it, that I find 47 concepts just as I did in Australia. I don't know where this terminology server is based, but wherever it's based, it finds the same thing, which basically means that our constructs are the same and the solution works, and I get a nice constrained list of chronic disease. So finally, I'm now going to move. Well, let me just say at this point, does anybody want to ask me anything about what I've done so far? And is what I've done reasonably clear and consistent?
It is reasonable, Charles. There was 47 and there were 46 on the previous server. So there is some difference, I guess, in terms of the what comes through.
So that may be about whether I'm seeing all the children and so on. So maybe the definition, or either Kylynn or John can give a view as to why there's one concept either missing or in addition in this list.
I think you're probably looking at two different releases. This one looks to be the American, oh no, sorry, it's just the international, whereas the other one, and it's the January of 2021. I think the Australian one only has June international plus the additional Australian stuff. So it's probably just due to the release.
Okay, so I'm now going to switch to this thing called Health Data Analytics, which is the tool that is a demonstration tool developed by one of the gang in Snomed International. And the first thing I'm going to do actually is start by just showing you the data that's in the system. So I'm not going to I'm not going to constrain that at all. I'm just going to fetch the cohort. And you'll see that there's nearly 1.5 million patients. And I would re-emphasize that this is a synthetic data set. And you can see that it's a bit fake because there are patients with an ID, a gender, and then no encounter. And then there are patients with some data, which is timed, and with a variety of codes relating to chronic lung disease, well, lung disease, not necessarily chronic, and various forms of and various procedures and inflammatory arthritis,
combinations of pulling data from all the different sources together. And it's really getting people to take data quality and the information as importantly as it seems to be required to give information.
Enduring codes with a date of onset and so on. I think that reflects something that happened in primary care going back into the mid-90s when commissioning of primary care was driven through QoF, and where essentially if you didn't do electronic data recording, you didn't get paid as a GP. And that incentive has over many years produced now a group of doctors who do encode everything at the point of care, and where there's very, very enduring and long-term data is a magnificent resource for the point of care, for creating exchange of data between systems, for providing access to data in the summary care record and other more local healthcare record systems, where the patient themselves can see data, and where increasingly the data are used for research purposes. And as I'm sure you all know, there's a year's worth now of Snomed encoded data in these systems, which I think perhaps was most nicely demonstrated during COVID, when the data from System 1 was illustrated to show the kind of profile that primary care patients, patients in the community seen by their GP were experiencing in relation to COVID. My own colleagues in primary care in East London published data for East London in the British Journal General Practice using Snomed encoded data from EMIS and populated into the integrating tool that we call Discovery. So some nice things are beginning to happen. But let me show you how one might use expression constraint language to create subsets of patients within this and then do a calculation. And the area that we've used this tool is to create to answer a question which I think is common enough to be really important to a large number of citizens. So many citizens have chronic obstructive airways disease. They have that either because they live in a town where air pollution is high and they're old enough to have endured the complications that air pollution has, or they're smokers, or they have inherited diseases of their enzymatic pathways. Whatever it is, chronic obstructive pulmonary disease is one of the most common illnesses that we have in the UK. And then we have rheumatoid arthritis, which affects probably something like 1.5 million, 2 million people in the UK, and which is a severely debilitating disease of the joints and causes deformity, an astonishing loss of mobility, comfort, and happiness, and which has been transformed in the last 20 years by the development of new knowledge in immunology, and where the core action of something called tumor necrosis factor in advancing inflammatory responses to unknown stimulants is probably the underlying cause of many inflammatory processes, and certainly seems to be the case in rheumatoid arthritis. And not surprisingly, both scientists and clinicians and the pharmacological and the pharmacy industry have responded by creating and developing anti-tumor necrosis factor agents. And when administered to patients with rheumatoid arthritis, anti-TNF agents have a miraculous effect on rheumatoid arthritis, reducing pain, reducing inflammation, and hopefully preventing deformity of joints because these are administered early in somebody's presentation. The problem is that if you're given anti-TNF, because it's a profoundly immunosuppressing drug, it opens up your body to the risk of infection. And if you have a pre-existing disease that causes infection, like COPD, then it's likely that the risk of developing serious complications in your lungs from the administration of anti-TNF agents is very high, or maybe higher. And we don't necessarily know the answer. Trials have been done, but we don't necessarily have the answer in our local communities. And here is a tool where you, if you had the data, you could do local searches for examining the additional risk of giving anti-TNF to a individual patient compared to your own local population, and where the numbers are high enough to make meaningful statements and to be able to express your worry as a doctor in a meaningful way to a patient, saying, you have COPD, you have rheumatoid arthritis, I think your arthritis will benefit from this treatment, but there are risks that we have to look out for together. And how might we do that? So let's build some disease constraints here. So we're going to make a new subset, and let's to start by defining interopen RA. And so our focus concept in this case will be a disease, as it was in the Onto server. And you'll see I have a disease. And I want to add a refinement. Anybody want to help me here with what attribute type we'll be trying to put in? Well, we're talking about rheumatoid arthritis. So this is a disease of the joints, isn't it? So rheumatoid arthritis will have a finding site. And let's hope it finds me a finding site. And the attribute target will be joint structure. I hope you're with me. And there's joint structure. And then there's some additional things we might want to help us to define an inflammatory arthritis, because if I just used this constraint, I would find any disease caused by any process to a joint structure, and that would be too open a definition. So let me restrict it further by finding an associated morphology. So there's an associated morphology, and what might be the associated morphology in somebody with an inflammatory arthritis? Well, in this case, it'll be inflammation. In a sense, it's in the name. So let's see if we can find inflammation as a morphological abnormality. It must be there somewhere. Let's see if I...
There's a concept, Charles, inflammatory morphology. Is that what you're after?
Yeah, that's what that is. So it's
Might be up the top now because
there we go. Okay, inflammatory morphology. And I want to add one more refinement, which is has a pathological process. So this disease has a pathological process. Whoops. There we go. And its attribute, as I probably tried to talk through, is about an abnormal immune process. So I think we'll find an attribute value of abnormal immune. Let's see what it pops up for me. There we go, abnormal immune process. So that's a reasonable definition of rheumatoid arthritis. And let me just try and open the window a bit. I'm going to save that subset. I just want to make sure it's there. So there it is. And I'm now going to show you, rather than create the additional subsets. I could just go back to the cohorts and find the cohort of interopen RA, and I'll fetch that cohort. And you'll see that I've already constrained my list from the 1.5 million patients. I found 76,000 patients who have some form of inflammatory arthritis defined by the constrained query that I've put in. Most of them are rheumatoid, but it would also find patients with psoriatic arthritis and other inflammatory arthritis. So if I go back to my subsets, you'll see that I've also cited one for chronic lung disease in the past. Yeah, perhaps yeah, there we go. So as before, it's a disease. It has a finding site of lung structure. It has a clinical course, which is chronic. I've also, crucially, created one for bacterial pneumonia, which has a finding site of lung. Again, I think everyone will know that a pneumonia affects the lung. The causative agent in this case, the risk that we're particularly interested in is bacterial pneumonia. It may be that altering a patient's immunity with anti-TNF will affect their predisposition to viral pneumonias. But in this case, we're going to restrict ourselves to just bacterial infections, and pneumonias have an associated morphology, which is inflammatory, just in the same way that arthritis does. So we've got autoimmune arthritis or interopen RA, as I have done in this case. We have bacterial pneumonia defined. We have chronic lung disease. And then there are at least half a dozen drugs that have anti-TNF in them. So we don't want to search on each individual drug. We want a overarching term for an anti-TNF agent. And if I show you that, then the Snomed term is a product containing tumor necrosis factor alpha inhibitor, in brackets product. So we have everything we need to make an analytical query on that 1.5 million patients. As I showed you, we've already refined it down to 76,000 patients with RA. I could go back to the cohort and show you how many chronic lung disease patients there are and fetch the cohort. So there's 150,000 of those. And what we're interested in is the intersection of the patients with RA who also have COPD or a form of chronic lung disease, and who either have or have not been given anti-tumor necrosis factor, and whether they did or didn't develop bacterial pneumonia. And then I can look my patient in the eye and say, you have both conditions. In East London, the risk of you developing a bacterial pneumonia because of the drug I'm going to give you to make your joints better is whatever we find it will be on our calculation. And then I can say, I think, with a much more open heart and a meaningful conversation, say, well, do you want to take that risk? Are your joints so bad that you really, really want to have this medication? Because I'm pretty certain it will make your joints better. And the patient, of course, might say, no, doc, I think that's too risky. I don't want to do that. Or much more commonly, the patient is going to say, yeah, just do anything you possibly can to make my joints better. If they give you that answer, then you can say, well, that's fine, let's do that. But let's also work with you so that you really understand the symptoms that might develop if you develop bacterial pneumonia. So if you develop a fever, if you develop a cough, if you develop purulent sputum, if you cough some blood, if you feel really bad, then you must make contact with the department and come and see us immediately, or make contact with your GP, and your GP will know that we're giving you this medication because we're exchanging the information about you using our HIE. So let me show you our way of doing the risk calculation. So, the patient, we're interested in the patient with chronic lung disease, and we're also interested in the patients with, what did we call it? Interopen RA. So there's the intersection of the two patients. And then we want to define the patients who either have or have not had a product. And remember, our product was anti-NF agent. Are you all with me at the moment? So we're looking for a group of patients who have got a rheumatoid arthritis, chronic lung disease, and we're giving anti-TNF to, and we want to know how many of them developed bacterial pneumonia. So I'll put that. So now we've got patients with chronic lung disease, patients with rheumatoid arthritis, who've been given anti-tumor necrosis factor, and we want to know what the chance of them developing bacterial pneumonia is. And in the perfect world, we would be running this on our live EHR database and giving the patients real data about their risk in the population from which they come. And that's precision medicine, personalized medicine at its best. And so I'm going to run that test, and it's going to whir away for a bit. And here you go. So this is the kind of tool that you might provide your clinicians in their clinics. So what it tells me is that from my database of 1.5 million patients, 10,000 of them had chronic lung disease and rheumatoid arthritis, and about half of them were suitable or agreed to have anti-TNF as a treatment, so about 4,700 patients. And of that group, 6.5% developed bacterial pneumonia. And in the group who didn't take anti-TNF, the incidence of the disease of bacterial pneumonia was nearly 3 times less. In other words, you were 3 times more likely of getting bacterial pneumonia if you had both conditions and you were given anti-TNF as a patient. So I think both the illustration of that increased risk and the discussion about what to do as an individual patient about being alert to the side effects of the drug and so on, completely changed the nature of the discourse that you would have a patient in real time. And the important thing, I think, with this is that this could be a real example in a clinic right now. And of course, you will all have spotted that exactly the same query could be applied to virtually every condition that you can think of. You know, whether that was treatment of a patient with cancer with chemotherapy, treatment of a patient with heart disease and diabetes and particular interventions, the risk of developing bleeding, gastrointestinal bleeding, if you have heart disease and you should be on an anticoagulant, but you also have a past history of gastric ulcer. What are the risks of bleeding, having GI bleeding when you're on aspirin and other drugs for your heart disease, but you've also got something going in your guts? Those questions are all real. They're highly personal questions. We all, as doctors, have a sense of the overall risk. We know it's probably worse to do X or Y, but we can't be very precise, and we can't give individual patients the kind of detail that these tools and the data allow. So I'm now going to stop and let you ask questions and also give John and Kylynn a chance to say, hey, Gutteridge, you could have done better. Why didn't you show them X, Y, and Z? Or anything else you wish to do, given that it's nearly midnight in Australia.
Yeah, I was actually wondering if I could share my screen and just maybe link this back to the FHIR terminology server as well.
Yeah, that would be great. Shall we just see if anybody does have any immediate questions?
And fire any questions.
Charles, I guess it was just around this was demonstration server, obviously, and so that answer about, you know, the incidence, likely incidence for your disease was a mythical one. But yes, you also talked in terms of the challenges of BARTs, who I have to say are probably miles ahead of my local area in terms of structured data or Snomed terminology. So in terms of getting it to the point of being clinically valid in terms of you're confident enough in the background data, how quickly do you think we're likely to get there?
So I think that's a great question, and in a sense, it's the core question, isn't it? There's obviously a first step, which is that you have to have an electronic health record, which is used by everybody. And so the National Programme for IT set out beautifully on that, but didn't achieve that aim. I think in London, we are much luckier than elsewhere in the country, where most trusts do have some form of electronic health record, but not all have a enterprise-wide one with the same data fields and the same ability to pick up data as we do, as you say, at Barts Health. If you're going with a best of breed type of solution, you may have beautiful solutions for each individual department. But, you know, in my example there of COPD and rheumatoid, if you had a department that was collecting data separately into a rheumatoid arthritis database and something else for their chronic respiratory patients, there's a whole additional challenge of bringing those two data sets together in a meaningful way in your data warehouse. And then there is the significant and exhausting challenge of persuading clinicians to enter point of care structured data into a problem list. As I say, I think that's happened in primary care. It hasn't happened in secondary care. I've been at it for what I think, well, this will be the 13th year at Barts Health. And although in a sense we've had interruptions, they're important interruptions. So when I started out, Barts and the London Trust was just the combination of the London Hospital and Barts Hospital, a smaller group. Over the period, we've added Newham University Hospital and Whipps Cross University Hospital, and so we now have a population base that covers something like 2 million patients, and more if you think about tertiary services, and a single system. But deploying or adding big hospitals to our original domain tested us grievously. It was extraordinarily hard work to add Whipps Cross and Newham to our original Cerner domain, with all sorts of real difficulties and imagined difficulties by clinicians and all types. So I would say the routine collection of structured data into electronic health records in secondary care is still a work in progress. It is a 5 to 10 year program of work, and it requires a health economy that has a bit of spare cash to actually buy the systems that work. So I don't know, I think, Andy, you're from Dorset, aren't you? So I don't know what the situation is, but my guess is there's work to be done.
I have a burning question. I'm sorry to jump in, but I want to just ask you very quickly about confidence, because you are operating there like a scientist, really, competently and confident in being able to get meaningful information back from your question to analyze it. Now, I take your point about it takes time to populate a system with real information, but you're putting it into the buckets here of Snomed CT. And I was most impressed by your confidence in Snomed CT to give you an answer. That for me was probably the most profound bit of your demonstration.
Yes, I'd agree. And I personally do have confidence, but I do understand people who would say, I want to test this further. I want to know that that's true. I'd want correlating data, first of all, from the front line, from clinicians that say, yes, this makes sense to me. This seems clinically credible. Or I've got a study where I've collected data myself, and these are the kind of intervals that we have. And also, obviously, you'd want to make sure that the original clinical trials that were done, for example, in the use of anti-TNF, where my proposition that there is a difference between the two populations is correct. So there are lots of ways, I think, of testing the assertion and using different kinds of data. But yes, I do have confidence, I think, in the terminology. I certainly have more confidence than my colleague who says, oh, I know what's best for the patient, and I just do, I have this feel. I'm the artist side of medicine, and I have a feel of what's best for patients.
I agree with you. It's a bit, but it's about, for me, I'm a mathematician, so it's about the granularity of the information.
Yeah.
600,000 individual descriptions is a very granular database to be working from. But the proof of the pudding's in the eating, and watching your confidence with it was really striking.
Yeah.
Charles, can I just jump in on that? Because I was in a similar place there, and one of the things that struck me was a couple of things really. One is it took a little bit of time to jump about to find that, and I think that's where the terminology server will help.
Yes.
Because it allows software developers to very easily interact with something that can do some of the work that you would having to do manually, jumping about. But do you, as a clinician yourself, do you see a future where actually if you're putting into a system that you're even considering giving a patient the anti-TNF medication, where actually the system will jump in and say, well, actually, and it can go off and it can do intelligent things in the background when it's looking at things like, well, ask them certain questions, raise a red flag on the risk, that sort of thing, where it can actually be, it doesn't require you as a clinician to think, actually, if I give somebody the medication, it's going to create a risk. The system will do that for you.
So yes, I think that is the dream state, an intelligent system that guides me, helps me, reminds me. One of the things I say often to medical students now is that as you can see from the screen, I'm an old bloke. I'm nearly 70. I qualified in 1976. And I did a medical course at my university where immunology wasn't taught as a specialty, because although there had been immunologists and things like the Coombs test had been invented, it wasn't really part of the medical curriculum. So I qualified in medicine without really knowing any immunology. And 50 years on, or nearly 50 years on, a whole branch of medicine has been developed, which is just amazing what you can do with it and how you can vary it. But the point of making that statement is that there is so much to remember now that I think no single human being can do it. And it's one of the reasons there are so many multidisciplinary teams, and each person in the team has a responsibility for challenging and reminding people to do the right thing. But these machines can help us do that as well, and do it faster. I'd agree that I think the chances of somebody writing an expression constraint query live in the clinic to get a bit of guidance on what to say to the patient is virtually zero. But I can see you guys developing us the kind of tools that you've just described and making that part of workflow. Absolutely.
Yeah. I can see it tying up with the likes of artificial intelligence as well, because I mean, I hasten to add, you're never going to take the doctor out. I hope to God we never take the doctor out of the equation anyway. But having like artificial intelligence type technologies linked in with something like this that can learn, essentially learning technologies, that can, when this is not just remembering, is it? It's there's new things coming along all the time, and a study gets published and suddenly you've got that at your fingertips because it's it's pulled into the system, sort of thing. That sort of thing is what I get quite excited about. As not a clinician myself, and as somebody who's been working in healthcare for 2.5 years and working in the finance industry prior to that, I get very excited about this sort of thing, because it's
absolutely. Absolutely. Another brilliant example of something that's happened this year is the discovery that dexamethasone may be helpful in people with very severe COVID infection. I've spent, again, a lifetime with people in ITU saying, yep, steroids can be helpful. And then 10 years later saying steroids kills everybody. And now we've got a set of data that says at a particular point, you can use dexamethasone and save a few lives. And it's really worth doing that. But it's the granularity of the data that's allowed to do that. I suspect it wasn't Snomed encoded, but that doesn't really matter.
That's the thing. I think machines can actually only count, and calling them artificial intelligence, they're not really in the way that we think of artificial. They crunch a lot of numbers and they do mappings and averaging. So that's mathematically how it works. They can only count. And that's why I was so impressed by your confidence in the Snomed CT encoding. If you wanted to be an accountant in healthcare, you might lean towards ICD-10 coding, because that's going to count your economic and your accountant's incident. It's not clinical in its approach, and that's why I was so impressed by your confidence.
Yeah.
So we're going to kick off now.
Sorry,
the point of these sort of classification systems is they achieve a different thing from a terminology. So they are that accounting, that reporting back at a sort of country level, rather than kind of understand the natural language or to get as close to the natural language a clinician would use.
Yeah. And I'll let you into a little secret now that we spent an inordinate amount of time debating whether we were going to call the terminology server for that very reason, and ended up settling on it because it's what people general knowledge. But we know very well that we've inaccurately named this product. But the terminology and classification system felt a little bit too long. So there you go.
Shall we let John just do his quick addition? But it's 1:10 and I'm not sure what our instructions were, but I think we'll have to rejoin the other group pretty soon. But John, over to you.
Yeah, sure. Can you see my screen there?
Yeah.
Post-screen?
Yeah.
Yeah, I just wanted to tie back what Charles was talking about, back to, if you cast your mind back to the presentation earlier, where Michael was talking about what a FHIR terminology does and the concepts that a FHIR terminology service deals with in terms of code systems, value sets, concept maps. Well, in fact, Charles has actually interacted with a bunch of those concepts right now, and you can map those onto entities within the terminology server and execute those operations programmatically against something like Snomed. So for example, our set of TNF inhibitor substances, we can define that as a value set. So Snomed is the code system, the set of TNF inhibitor substances is the value set, and we can define a value set that is all of the codes that are subsumed by say this 2-necrosis factor alpha inhibitor containing product, and we can define that and save that within our terminology server, and then we can actually go ahead and expand that and say to the terminology server, okay, give me the actual codes in that, and it will give us all the codes that are under TNF inhibitor substance, and then we have these set of codes. But what the next thing Charles did was he took his data that he wanted to do analytics on, and he did the intersection between the codes that he found in the data and the codes that the terminology service says are TNF inhibitor substances. So here we're doing a value set expansion, but we're actually doing a value set intersection. So we're actually saying, here's 2 codes that I've encountered in my data, one of which is a TNF inhibitor and one of which is not. And here's a value set that I've defined that says this is all the codes that are TNF inhibitors, and give me the intersection of that. And it's come back and it said, well, this one is in the set and the other one isn't. So this is, I just want to sort of tie that back to say, you know, this is all stuff that you can do relatively easily, programmatically interacting with a RESTful API on a FHIR terminology server.
That's fab, John, actually. Really nice. Might like to take a couple of screenshots of that one day. So I think we should rejoin the main group. Is it Kylynn or John? Do you know if that's correct? Are we meant to be returning to the gang, or can we chat away for a bit?
I suspect Helen will call us back in or close the room, and we'll all tumble back when she's ready if she's
okay, so it was
say 1/4 past, so we're probably not very long.
Well, let's continue the discussion then, which has been great so far.
One thing that struck me is against Andy's point, actually. Oh, hang on, it looks like we're being called back, actually.
Okay, yeah.
That was absolutely fascinating, Charles. Thank you ever so much for that. I've learned a massive amount.
Yeah, it's brilliant.
It was a pleasure.
Brilliant.
Really good.
Well, see you on the other side, so to speak.
Yeah.